Hi, my name's Nick Highton. Currently been acting as the engineering manager for S&C Alliance, the North S&C Alliance for the last 2 years, working on the northern programmes. That includes Phase 4, Manchester to up to Preston, and Phase 5 around ASHTON and Staley Bridge area. So we're just going to try and tie together kind of Neil's presentation and Andy's presentation, and more talk about kind of the implementation side of things and the pitfalls and the things we've come across over the last 2 years. The difficulties that you come across trying to build a compliant platform, which I think is a common problem that everyone seems to be encountering in the modern times. So first, I think Andy touched on it in terms of track and civil staging. It's really important, and that's probably a bit that gets missed 9 times out of 10. So we've been looking at recently, the historic challenges, positive clearance versus the compliant heights and offsets, and sometimes tied into rolling stock that a lot of people are familiar with, things like the 153 and the 155. The actual implementation of the scheme, you've got a track contractor building track and a civils contractor building civils, and the interface between the two, sometimes forgotten or not managed correctly. And I think, as Neil touched on, the interface between the group standards, the construction tolerances, the gauge clearances, and the rolling stock that operate on the route, all working against each other to try and put a problem there that's unsolvable. And then as built, the final point, compliant construction aligned against clearances and compliant dimensions. And looking how we've come across a 2-year journey, the experience to date and prior to that really, I think again, as what Andy touched on, ineffective management between track and civils, handover points not kind of defined, so people starting to do things where there's no control points in place, and no specification again of actual construction tolerances, so no one kind of setting out with a goal of what they need to achieve a compliant scenario. And just at the bottom there, the result tends to be, in our experience, a non-compliance to a group standard. It's very difficult then in the end to get past somebody like the NCB or the certification board, and then needing a derogation, which you shouldn't need in theory. So items we've put in place across Phase 4 and 5, we developed what we classed, it's quite a snazzy title, an AIDD, Agreed Interface Definition Document. And the idea behind that was to kind of pull together the civils and the track scope. So specification of platform heights and offsets, specification of enhanced construction tolerances where needed. It coordinates the track and civils activities together with hold points in place and sign-off positions, ultimately ensuring compliance with group standards. And the bottom one, it specifies the key construction sequences and, more importantly, any hold points and handover points. And I think Neil touched on this in some of his slides in terms of compliance, and more on this slide in terms of as-built compliance. What does that actually mean? And I think there's definitely misunderstandings of that from a group standard point of view, from a gauging point of view. I mean, from a track point of view, it's quite straightforward. It's the track construction standards 2102 for a given line speed is the minimum that we'll achieve unless we specify enhanced tolerances. In the group standard 7016, again, as Neil touched on, the Y dimension typically 915, but you have got a 25mm corridor down to 890. And from an offset point of view, 730 plus 15. And the overarching mandate in 7073 is the prime requirement isn't necessarily normal clearances or reduced clearances, but positive clearances, making the best use of clearances versus stepping. And an important one again that Neil touched on really was in standard 7073, the maintain position and the effective position. And the maintain being, in our terms, that I think Neil did touch on it, is almost identical to the reference position. It is the design position. And more importantly, the X and Y compliance on site is to that maintain position. It isn't to the as-built position or effective position. And an important one at the bottom that we've worked on over the kind of, again, the last couple of years, in terms of to the design position, that is using all the track tolerances, whether that be low fixity, medium fixity or high fixity, in the clearances that are calculated. But in terms of the effective position and what is built on site, the actual clearances are calculated, in effect turning the tolerances off. It's a given position on a given day, and then with the clearances that you end up with on that time. So again, if that's positive, it is a compliance. We're just going to come on now to kind of some, I guess, real-life experiences over 2 stations, BOLTON Station and ASHTON Station, which between them are both defined as CSM significant projects. So both fully reviewed by NCB with a safety assessment report and TSI compliance as well. So BOLTON was a 9-day blockade. There's 5 platforms in that which were constructed by Buckingham's. 2 new platforms, Platform 5 and Platform 2, that were CSM significant, and then track tamping and full recopering across platforms 1, 3 and 4. We went into this kind of with a type of proposal where we wanted to put in enhanced construction tolerances. So our idea would be that the track was built first, the track was installed first, and we'd build that to a very, very tight tolerance, well inside the track construction tolerances. So track vertically was plus 0, minus 10, and horizontally plus or minus 5. And the idea behind that being the civils guys could then go out with their standard heights and offsets, 905 and 735, work to very tight tolerances of probably unachievable, plus 0, minus 5, and plus 5, minus 0. And if they did that, you would end up in the green boxes here, and you would have been compliant in the as-built position, and in the effective position, and in the maintained or design position. But in real terms, we were in a 9-day blockade, a lot of pressure to get certain platforms open, and we never got the track within these enhanced tolerances. So a procedure we've then kind of adopted really throughout Bolton Station was, because we couldn't achieve the tolerances, we then developed adjusted heights and offsets. So we had our design offsets for platforms, which were 905, 735. We had an as-built on site, that's kind of the difference where we installed our track to. And these were modified X and Ys that the Buckingham Group installed on site with a specified tolerance. And based on that, that was their as-built position on site, which, as Neil touched on, the as-built position or the effective position isn't the one that needs to be compliant against the group standard. That isn't the one that needs to be within 890 or 915 or 730, 745. It's the maintained position at the end. So as you can see as an example on, I think it was Bolton Platform 5, fully compliant, all heights and all offsets within the parameters of the group standard. And that was kind of, I think the next slide shows, that was kind of mirrored across the platforms. So in terms of the two CSM significant ones, we had 100% compliance. So in terms of authorisation from the NCB and the safety assessment body, that was fine. And platforms 1 and 2, 1, 3 and 4, these were built around existing track, and in the end the track itself was not in great condition, in relatively poor condition, with large lifts and large sloughs from a tamping point of view. But compliance wise, you can see over 95%, so still quite a good outcome in reality. The second station was ASHTON Station. Again, this was a full station rebuild over a 14-day blockade. Full track renewal, full platform renewal, and again CSM significant, so a significant project. Now, the key difference on this project was due to the blockade and due to all the timings in the blockade, the platform was constructed without any track in situ. So it kind of dictated that we needed to use coordinated techniques to actually build and install the copers. And they were installed using a total station and a rail shoe, and specified with tight construction tolerances from a platform and a track point of view. Now, in terms of compliance, the up platform was fully compliant, and the down platform, we ended up on site with marginal non-compliances that can be seen on the next slide. So similar to the last point really. In effect, both platforms compliant in an as-built position, but looking at the down platform, once you implement the proposed lifts and sloughs to the design or to the maintained position, marginal non-compliances to the group standard. And that was largely, if you look back at the previous slide, largely as a result of specifying specific platform dimensions, 740 and 890, dictated by a rolling stock that operates on the route. And this location, more specifically, the 153 and 155. And I know Kev Mellor's in the room, so recently these guys have done work on them specific vehicles to improve the clearances to those. So in reality, this problem would not exist anymore. So I think if we took the project on now, we would have specified more realistic heights and offsets, probably 900, 905, 915. And I think the compliance would have been much more easy to achieve. Just touching on, moving on to some lessons learned. Bolton Station, so that was kind of constructed in a traditional way. Tracking first, platforming after, in a blockade scenario. As we touched on earlier, very difficult to achieve what we tried to achieve, tracking very, very tight tolerances. We ended up with delays on site because of the blockade and because of the pressure. The construction guys needed the X and Y's recalculating based on these bespoke heights and offsets before they could crack on site. So it did present a couple of delays during the project, and obviously copers couldn't be installed before the track works were completed. And one interesting one, which I think is a really important one for traditional setting out, when we visited site one day, they're establishing a project chainage on site. So the track guys had established a chainage, and the civils guys had established a chainage. and there was 2 metres apart on the chainage. So there's two different marks for the same chainage. So it's very important. I think me and Andy touched on it yesterday. It's very important to mark out that chainage, a common chainage. It's very, very important. ASHTON presented different problems. This was installed coordinated, with a coordinated system, with a rail shoe, no track in situ. We did loads of prep. We had loads of prep meetings with the Northern Programme Surveyor Manager. And even though we prepped, still had issues with survey control on site, and it seems to be a common theme. Secondly, in terms of the construction contractor, my experience is they don't like installing platforms this way to coordinated kind of techniques. It did require an engineer or a surveyor to be on site all the time with that specific capability. And I think the main one, the copers are obviously installed in that scenario independently of track, whereas the actual compliance is, the group standard is heights and offsets. So the 2 things are done separately. Your surveys are there separately, surveying track and platforms. It's very difficult. And I think what they ended up encountering on that scenario with installing it coordinated, they had the copers up and down 5 or 6 times to get them even in the right place. So quite challenging, I think. And this was the final slide, really, just to touch on kind of the pros and cons. And there's probably no right or wrong way in reality. I think if you choose one way and it's dictated by certain scenarios on site, and then that has to be the way it goes. But these are just kind of pointers where the pros and cons for either. So for traditional, in our opinion, the setting out of it is much quicker. Using a platform gauge, a guy in a platform gauge, it's very quick. It gives you a direct reference to the track, whether that would be its effective position or maintained position. And there's no real specific competency to read a platform gauge as such. And the cons with that one, it can't be, your copers cannot be installed until the track is in the right place. Chainage datum is a key one, and that'll go on following forward. And it does require on-call design support in terms of generating platform heights and offsets. And from a coordinated point of view, obviously the platform can be installed without the track being in situ. I think there's a pro and a con for it being installed independently. I think I have it on both slides. And the coper string on curved platforms, which again, there are a lot of curved platforms in the country, you can pick a reading every metre, every 100 mil, every 5 metres, it's continuous. So it does aid on curved track. And I think the real negatives from the coordinated one, perhaps lack of experience, the negative of it being constructed without a reference to the track, setup errors, survey control, different incidents can all lead to errors being brought into the system. It requires specialist staff. Survey control seems to disappear amongst contractors. OLE guys rip it out, various people dig it up, so it's always problematic. And I think the last one, it isn't predicated on X and Y's, so then trying to prove compliance against 7016 from a height and offset point of view can be difficult. You still need to use a platform gauge at the end of the day. So that was a summary really of our last 2 years in BOLTON and ASHTON.